let's look at working with tangents. So in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint on the circle, which is the point of tangency. So notice here we have circle X. We know that line L there is a tangent because it is perpendicular to the radius. And the radius of our circle there goes from the center to the edge. So XB there is a radius. Since line L is perpendicular to XB at point B, then line L is a tangent. So line L is tangent to a circle. That stands for if and only if line L is perpendicular to XB. And that means B would be the point of tangency because that's where it intersects the circle. So, well, when we have perpendicular lines, we can create right triangles. So we can use properties that we've learned in the Pythagorean theorem section and solving with trig ratios section of our lessons. We're going to primarily be working with Pythagorean theorem, right? But we'll work a little bit with trig ratios. We'll do one problem. So what must be the length of LM for this segment to be tangent of the circle with center N? Because the tangent is perpendicular, meets at a right angle to the radius, we can use Pythagorean theorem to find the length of LM. So remember when we were learning the converse of Pythagorean theorem, that if leg squared plus leg squared equals hypotenuse squared, then we had a right triangle. If that's a right triangle, that makes that segment LM there perpendicular to the radius, and it makes it a tangent. All right, so I have some notes that you can add. This is in your, I believe this diagram is in your notes. If LM is perpendicular to MN, then LM is a tangent. We can use Pythagorean theorem, and you should always use Pythagorean theorem if you know two sides of a right triangle, and you can use that to find the third. Don't try to find an angle using a trig ratio and then use that angle to find a side. That creates all kinds. You have double rounding error in that. Instead, when you have two sides of a right triangle, it's always Pythagorean theorem. And add this to your notes. If you have a tangent and a radius, think Pythagorean theorem. Because remember, they're perpendicular. So you can, it's always going to be worked out. It's always going to work out as tangent squared plus radius squared equals hypotenuse squared. So here, let's go ahead and find the length of our missing side. So the tangent is x. The radius, that's mn, that's 7. And this hypotenuse, it goes from the center of the circle to the tangent. That was LM, and that's 25 squared. 7 squared is 49. 25 squared is 625. If we subtract, x squared is 576. And then if we take a square root, now remember we're going to be seeing some problems where we can take a positive or a negative square root. So here we're only going to take a positive square root because this has to be a measurement. Right? So we take the square root of x squared and the square root of 576. So square root of x squared is x. 576 is a perfect square. Let's say you didn't know that it was a perfect square. Right? A number that obviously goes into 576 is 2. Right? It's an even number. So that would be 288. Right? So 288, 2 goes into 288. Goes in 144 times. 144 is 12 times 12. I don't have to keep breaking down the 12s. I already see I have a pair of 12s. So take 1 12 out, 1 12 goes away, 1 2 goes out, 1 2 goes away. And so x is 2 times 12, or 24. Right? So if you're working with tangents, just use Pythagorean theorem. Right? Once in a while I might throw in a problem where I give you an angle measure, but if you've got two sides of a right triangle, then it's going to be Pythagorean theorem. And I think if the ones in your notes are Pythagorean theorem, excuse me, in your homework are Pythagorean theorem. I don't believe there's any trig in your homework. And we're just waiting for the page to turn. All right. right, so what must be the length of YK for this segment to be tangent tangent line of the circle with center X? All right, so remember, you can use Pythagorean theorem because the tangent is perpendicular to the radius. So here YK is perpendicular to XY. And it's always going to be that tangent segment plus the radius squared. So the tangent segment squared plus the radius segment, let's put radius squared, equals the hypotenuse squared, which is that line segment that connects the center to the tangent. So the tangent is x, the radius is 10, the hypotenuse is 24, 10 squared is 100, 24 squared is 576. We just saw that on the other page. Subtract 100 from both sides, so x squared is 476. Now this is not a perfect square. So we'll take a square root of both sides, but we're definitely going to have to simplify the 476. So that's just x. All right, so actually I'm going to wait to write the x. Well, I'm sure that 4 goes in. All right, so 4 divided by 4, that'd be 1. And then 4 divided by 7 is 1. And we'd have 3 left over, so that's 119. Well, guess what? 119, that is a prime number. So you can break down the 4 into 2 and 2, but you can't do a darn thing with 119. So I'm pretty sure, let me just try one thing, but I'm pretty sure it's prime. I'm definitely sure it doesn't simplify. Yeah, it's prime. I tried one last choice number in there and it doesn't go in. All right, so 1, 2 comes out, 1, 2 goes away. So x is 2 square roots of 119, and that's it. We have found it. So that's what x would have to be for it to be a tangent, because now Pythagorean theorem would hold. We could check that out too. All right, so let's check it. All right, so if Pythagorean theorem holds, we have our hypotenuse squared, which is 24. That would have to equal the tangent squared, which is x. Oh, excuse me, which is 2 square roots of 119. Plus the radius squared, which is 10. So this is 576. All right, so if you're squaring and you've got a number and a radical, you square the number and square the radical. And of course 10 squared is 100. 2 squared is 4. Square and square will cancel, so that's just 119. So this is 576 equals 4 times 119, that's 476. And you see it checks out. So if you weren't sure, you could always check it out. Right? And I'm not sure if this one's in your notes or not, but I'll go through it with you in class and we'll find out which ones were in your notes. We're going to do a few more problems, and we're going to learn a few more theorems about some chords and some tangents. All right, so this is going to be my one problem that's going to be a trig ratio. So we want to solve for the radius if AB is a tangent. So if AB is a tangent, it means that XA has to be perpendicular to AB, which means you have a right triangle. You can use trig ratios if you know a side and an angle in a right triangle. Right? Let's identify which side and which sides we know relative to our angle. Right? So across the triangle, that is the opposite. And AB is the other leg, it is the adjacent. Of course, opposite the right angle is the hypotenuse. We're looking for the opposite. We know the adjacent, that would be tangent. So we have tangent 20 equals x divided by 12. Multiply both sides by 12. We have 12 tangent 20 equals x divided by 12 times 12. That'll cancel. We have 12 tangent 20 equals x. At this point, I can use the table or I can use the calculator. Just a little easier for me to use the calculator. So, at least while I'm recording. So, I'll grab out a calculator. All right, so 20, there's the tangent ratio for a 20-degree angle, and then times 12. All right, so we have the radius is around at 3 decimal places, 4.368. There we go. All right, nice little review of trig there. All right, so just remember that the tangent is perpendicular to the radius, which means if you know two sides, you can use Pythagorean theorem. If you know a side and an angle, you can use a trig ratio. And just waiting for the page to turn. There we go. Determining if a line is a tangent. Because the tangent is perpendicular to the radius, we can use Pythagorean theorem to determine if a line is tangent. Essentially what this is that we're using converse of Pythagorean theorem. If we do not get a true statement using Pythagorean theorem, then the line is not a tangent. So if hypotenuse squared, or which is in this case the longest side, does not, if it equals, let's go through what it equals. If it equals the radius squared plus the tangent squared, then we have a right triangle. Excuse me. We have a right triangle, and this is really a tangent. The segment is a tangent. And this is just essentially the converse of Pythagorean theorem. We have the sides. We're not solving for anything. We want to see, are they sides from a right triangle? Here's our first one. I think this one's in your notes, but I might have changed the numbers. Just for some different numbers. The one number was just so large, it was kind of obvious it wasn't. It was so large, it didn't even make a triangle. So obviously it couldn't be a right triangle. So I changed it to 90. At least let it be a triangle. All right. Remember, the largest side in the triangle has to be smaller than the sum of the other two. Otherwise, the poor other two legs can't even reach it. All right. So now we're going to set this one up. So our largest side there is 90. So if you're never not sure, which goes where, just remember the largest side is the one that's isolated. So 90 squared equals, and then the other two. So 21 squared, and the one that looks like it might be a tangent, who knows, 72 squared. Getting into calculator here. I can do 90 squared, that's 8,100. I think 21 squared is 441. Oops. I got all kinds of numbers on here. Yep, that one is 441. Just looks like it should be, doesn't it? But I do not know 72 squared. 5,184. And I should put a little question mark here because we're deciding whether it equals. Well, 8,100 does not equal, let's see what it's going to be. It's 526. So 5625. So 8,100 does not equal 5,625. So this one is not a tangent. So AB is not a tangent. And I have some information below. All right, and I'm going to scroll the screen up so that you can see it in a moment. Let's try the next one. All right, again, do the same thing. All right, the longest side is 50. So 50 squared equals, and then radius, and what looks like it might be a tangent, 49 squared. Of course, we could be wrong. 50 squared is 2,500. 20 squared is 400. And 49 squared is 2,401. And again, I should have put question marks here because we're finding it out. But 2,500 does not equal 2,801. Right? Matter of fact, that would be if we were classifying triangles. Let's see, the first one would have been an obtuse triangle, and the second one would have been an acute triangle. So again, XY is not a tangent. And let's review why not. There we go. All right, so using the converse of Pythagorean theorem, neither triangle is a right triangle since Pythagorean theorem did not hold. Therefore, AB and XY are not perpendicular to BC and XY respectively, and AB and XY are therefore not tangents. Right? So when you're asked to explain something, this would be considered an explanation. Some vague gibberish, leaving the reader to interpret, is not an explanation. Here, I'm not leaving anything for you to try and figure out, right? I'm telling you what theorem I used, what we discovered, and why. All right? That's an explanation. So here's our explanation. All right, so if you're asked to justify, that's how you justify, using the theorem, and you write it in a sentence that somebody could understand. If you just write make a phrase or a few vague words, then people aren't going to be able to interpret it. Determining if a line is a tangent. So how long is SO? All right, so here we actually are told that this is going to be a tangent. We're going to determine, we are determining. We have to find SO. And then we're going to determine if this is a tangent or not. So how long is SO? Use Pythagorean theorem to determine if MT is a tangent line. Because we can figure out SO without MT being a tangent line. If you notice, look carefully, what's SO? So SO and OT are radii, and this one may or may not be. I had two versions of the notes. One version had them in there. I'll actually try to get these notes to you so you can actually take notes on this problem. So SO and OT are radii of circle O, which means that SO is congruent to OT. All right, you do see some problems like this on the homework and possibly benchmark, informative, and test. Just figuring out that this right here is a radius, and this has to be 20 as well. All right, OT equals 20, SO has to equal 20 as well. So now we have the side lengths of our triangle. Right, so the radius is 20. The tangent, or what looks like it could be a tangent, what we're checking to be a tangent, well, maybe we should call it question mark tangent, because we don't know if it's a tangent. It's only a tangent if Pythagorean theorem holds, is 21, and that's MT. I guess you can read that. And then MS is the longest side. We're checking this. It's only really called the hypotenuse if this is a right triangle, but we'll just call it hypotenuse. But it is because it is the longest side. And we're going to check, does Pythagorean theorem hold? Right? So we have, so we're going to, when we set this up, it's going to be SO squared, or excuse me, OT squared, technically OT, right? Although SO is the exact same measurement, OT is the radius that makes up one side of that triangle. That is just driving me crazy. And wait a minute, empty. Okay, let's see if they hold together. Nope, but no. No, no, no. Undo. I don't know why it thinks, because I'm moving it around, it thinks, hey, Mrs. Machagna wants to ungroup it. She wants a bunch of random little squiggles. Even though she wrote them all together. All right. So we have OT squared plus MT squared. Does that equal MS squared? Do we have 1 that works out? So that would be 20 plus 21 equals 29 squared. That's 400. That's 441. 29 squared is 841. Hey, one worked. So 841 does equal 841. So using converse of Pythagorean theorem, that's why I wanted to have this one. We had to have 1 that works out. Triangle OMT is a right triangle making angle T a right angle actually I'll just make this a real one sentence. And making MT, the line MT, perpendicular to line OT. Therefore, MT is a tangent. And since MT keeps on going, we'll use the line symbol. We have segment MT that we used to do converse of Pythagorean theorem with. But the actual tangent is line MT, and I can't seem to make that. All right, how about now? Oh, no, it's too big. There we go, now it fits. So there we go. All right, so when you were learning converse of Pythagorean theorem, you were also learning a way to determine if a line segment was a tangent. There we go, now that fits. All right. And I think that might, let's see if this is, yep, this is where I'm going to stop. So you can wonder about that weird clown, because that's going to go into the next video. So I'm going to pause, and I'll see you in the next video. Bye for now.